Hi guys, I might have talked about AI agents a few times already in this channel, but in this video I'm going to talk about agent to agent or A2A protocol. This is something that was introduced by Google in April 2025, and right now it is open source under the Linux. And this one we're going to talk about what is it and where we can use it and what are the different use cases of it. So without further ado, let's jump right into it. Welcome everyone to our channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedram. I have a PhD in computer science, and in this channel we'll talk about AI and machine learning and how we can use it in order to improve our efficiency. As we said in this video, we're going to talk about A2A protocol. So we have seen the agent itself. This is something that will start from perceiving the information from the environment. It will try to make decision based on the specific thing that it perceived. Then it will try to act on what is the next step, and finally it is going towards achieving the goal that it wants, and its goal might also require to do further perceiving and making the whole loop complete. But there are some cases that we cannot just rely on one agent to take care of the whole task for us. There are a few cases that it might be complex to have one agent to do that persistently and consistently in a successful way. And in those cases we want to have two or more agents around them completely separately, and they can actually talk to each other in order to do the communication and further complete the task. So as an example for here, we can talk about a traveling agent. So why a traveling agent might be one of the cases that require multiple agents is because it has different components. It can have the one that take care of ticketing. There is the one that can take care of basically the hotel booking, and there is one other that can take care of the activity. And as you can see, these components, although they are related to each other, for example in terms of the time, the location, but they serve completely different tasks, and making one agent to do all of them at the same time may make the problem not very specific, and also make the consistency of it very low. And for that reason we actually want to have a communication between these agents. So what a good protocol can look like is basically from a different aspect. So we care about the communication. We want them to actually be able to communicate to each other very well, and for that what is important is basically we want it to be some standard and a streamlined operation. And after communication we want to make sure that they have the proper authentication. If I have an agent, I don't want unauthorized access to it, which is basically very obvious. And after that, I care about privacy, which is basically I want my concepts to be only private to myself, and secure my IP access. So these are basically the few of the characteristics of a protocol that I need when I want to define two agents talk to each other. So now let's take a look how A2A actually try to implement this. In a communication, we can start from a user. The user can be an actual human, or it can be another basically agents that try to initiate a call. Now what it does is that first we'll talk to something called the client agent. So the client agent in here will take care of the communication with the user and make sure that it have the correct form of communication and data that is required for our remote agent. What is the difference between remote agent? So the remote agent, as its name suggests, it is actually happening in the remote server, and the client agent can actually happen on the edge devices. This is designed to make sure that we have privacy, and also at the same time we have the scalability. Remote agent might require so many different components, and we don't want all of them at the same time, so it doesn't mean to have it on the client side. And it's kind of also very much in line with what we have for the design of, for example, UI design and backend design, or any microservices which actually have a user front end and the back end. So in this communication, how they actually talk to each other specifically for agent is A2A protocol. So this can basically initiate the communication between them and try to get the response from what we want to do. The first thing we might say is that how this actually will recognize this remote agent. So that's basically very similar to MCP or Model Context Protocol. I put the link at the end of the video if you haven't seen, but basically this happened through the self-discovery. So same as the idea that we have for the MCP, the remote agent will actually try to publish something called the client card. So the client card is act like an ID for the agent, and it will take care of whatever information that agent needs, whatever authentication it needs, and how it will try to work, and any other task or benefits or whatever things that it has will actually be inside the client card. So the discovery aspect will actually happen through this client card, which the agent will take a look at it and say that, okay, I have this agent available, and now I can basically talk to it in this way. So now that we have the discovery out of the way, the next step from the things that we care about is basically the authentication. When we want to have two agents talk to each other, I want to make sure that I have a proper authentication going on. So in here, we're gonna basically have at the same time we're gonna have a clients in here and then a server on this side. So when we want to do the authentication, they will basically try to send their information about their authentication, how they understand it based on this client card. So inside the client card, they will say their preferred method of authentication, and then they will try to send it. So is it beer token, is it like, for example, client sign authentication, whatever it is, you will try to provide the authentication method, and then after that the server will try to either grant it or try to deny it. So that's a very conventional approach of any microservices that try to basically communicate to each other in order to make sure that the authentication is successful. And after this authentication, we have the actual communication. So the communication, how it's done, is basically we have our client. After it is authenticated, it will try to submit a task. So that's basically what it wanted to achieve. Again, how it will be done is through this client card, which is basically a simple JSON which contains all of this information, or what tasks that it needs to be done and what are the input parameters for it. And the conventional approach for it is through HTTPS, so it is a secure connection, and RPC 2.0. So that's another very conventional way of how API also talk to each other securely. And then when we have through private and public keys, and then when they try to provide the task that it wants to achieve, it will try to start its process under the hood. So it will try to start some process in here and then see where it can go. But then based on that process, there might be a few cases it might want to ask some additional information. So if it wants to ask some additional information, we can talk to the client, and then the client will also provide the additional information back to the server. And when they are completed and they have finished the process, they will provide the final response back to it, which can be an artifact. So the artifact basically is any tangible document that is generated as a result of this process. It can be a generated image, it can be a generated text, PDF, or a simple text response. That is the general final result that will go back to the system. There are some other special cases that basically the agent on the server side will actually might want to do some tasks that require a streaming, which means that there are some cases that as a step in the accomplishing the task, it must require to get some input from the user. These are called the human in the loop, and they are not like a client server request response back situation. They'll need more persistent connection, and for those kind of scenarios, if the agent card actually mentioned that it accepts the streaming, so streaming is another way of communication with a persistent connection that allows to perceive additional information via user command, which there is no timeout on them. So they can actually provide that layer of communication through a very conventional way of the communication, which basically make sure that they can enable this streaming through the SSC and other conventional streaming that they can wait until the user response to actually get the final response back. Now, as the agent on the server side is doing the processing, even though that we are sure that we have done and completed basically our authentication and we granted access, but still we might not want the client to know some proprietary information, some IPs and so on. So an important concept in here would be the privacy. So the privacy that can happen both from the server side and also the client side. The client might have some information and we won't want to expose to the server. So the privacy is a very important component for any sort of communication protocols that need to make sure that the communication stays secure and completely provide the response in a way that we can generate the response. For example, for SSC, we have do it through the HTTP. And there you have it, guys. We have talked about agent to agent or A2A protocol that establishes a standardized and a streamlined communication between agents to enable accessing and doing some complex tasks. So this one we talked about. This is a very new concept, and there are so many things that needs to be improved on, specifically on the privacy information. Since these are open source right now, we can get help of the community to get this on the best version that it can be. And another important aspect of it was the standardized processing of it. For example, it has the JSON RPC, it has the SSE, it has the configuration through HTTPS, which are very common and conventional approaches, which make the communities and the companies very simple to streamline and provide the response and employ them. So if you enjoyed the video, make sure to like it. More importantly, subscribe to the channel. If you want to see more videos like this, I have talked about MCP in here, Model Context Protocol, that share a lot of commonality with this A2A agent. Or you can watch this one talk about top 5 prompting guidelines that you can use regardless of what LLM you are trying to use, which make your life a lot easier. Thanks for watching and see you until the next one.